Okay, so to get started with physics, you need to create a cube in a plane and shrink the cube in scale and leave the plane basically at 0. And so to start with, in order to once you get that done, in order to create a make this object respond to physics, what you need to do is you need to select it in the hierarchy. You need to go to tags, and you want to go down to simulation tags. And under simulation tags, you'll see there's several things in there, and we're going to talk about cloth at a later date. But you're going to see rigid body, soft body, and collider body. Those are the three, and ghost body actually as well, but we're not really going to talk about ghost bodies right now. But we're going to choose rigid body. And rigid body just means that gravity will affect this and other forces can affect this as well. But it's not going to deform the mesh when it hits something. So if I go ahead and hit play on my playhead down here, you'll see that my cube falls and then obviously resets. And it's going straight through that plane, right? Because the plane is not involved in the physics engine at all right now. And so it's basically invisible to the cube. So let's go ahead and stop this. We're gonna, and it's always a good idea once you hit the playhead to stop, just to pop back to the 0 frame here so that we're where we began. And so now to make this plane respond to physics, I'm going to select the plane. I'm going to I could right click on it and go to simulation tags and go down to collider body, or I could go up to this little tags menu and go down to collider body. You cannot see it on this screen because of the way this, well, maybe you can in the video, but not on the projection. But there's a simulate menu as well up at the top. And I can't remember if no, I think you just have forces and dynamics. But they don't have, they don't have the other simulation. You can't create rigid body tags up there. So now when I go ahead and hit play, the cube drops and then bounces a couple times on the plane. And I have this cube pretty high up. If I was to bring this closer to the plane and hit play, it's going to change how that physics, how it reacts just a little bit. Something to note, if I play this and then stop it somewhere and try and move this cube, if I am not on frame 0, if I'm somewhere in the midst of that physics calculation, I will not be able to move the cube, It's going to be wherever it is until I pop back to frame 0. There's a way around that, and we'll talk about that in a bit. Okay, so great, we can make a cube fall. So there's a lot of settings that can change how this reacts. And to start with, if we click on the rigid body tag, and then I'm going to go ahead and hopefully, hold on, I'm going to go and do something real quick that hopefully won't take too long. I don't want software update. I need accessibility. Where are you? Okay, let me make sure this works. Hey, look at that. Okay, great. So in the attributes, when I have selected the rigid body tag on my cube, you can see there are a bunch of different options. If I go down to basic, we can give this a name. There's some other options we have here, but it's nothing that we're really too concerned about. Typically, the first thing that we want to look at is the dynamics tag. The dynamics tag, this enabled means physics is enabled on this. You can see that it is on, not off, or in ghost mode. We can set an initial state, clear an initial state, and we'll talk about those in a second. And there's some other deactivation and stuff. And basically there's like a threshold where if it's moving below a certain speed, then it stops being, like it just sort of stops. And that works. The tag that's most important to us is the collision tag, or tab, the collision tab. Under the collision tab, self-collisions, this doesn't really matter so much when this object is just a cube because it can't possibly collide with itself. But if we had multiple objects that were, say, clones or children of a null, then self-collisions is something we would potentially want or maybe not want. These are all set by default. The shape is automatic. There's a lot of different options here. We're going to leave it on automatic. But what these do is, depending on what you're working with, basically what you want is you want the simplest mesh, collision mesh, which is different than your actual objects mesh, as possible for your needs, because then it makes the physics calculation go that much faster. So like for this, it's probably using box because it's a box. Ellipsoid, right, would basically be like a sphere. But then there's cylinders and different axes. There's what's called a convex hole, a moving mesh, a static mesh, another object. And so for a convex hole, that's like if you had a bowl that you wanted, say, something to fall into. By default, it would actually be, it'd be like it had an invisible lid on it, and stuff would just bounce off the outside, but convex hole would wrap it in there. Static mesh means the object isn't moving. Moving mesh is and it's sort of like, this is cheaper in terms of the time it takes to render than this. And this, basically, these top ones are less expensive, and it kind of just moves in terms of expense until we get down to static and another object. And that doesn't matter at this point, but if you had like hundreds of objects that you were doing, it would take forever to render a few frames, or to like, not really render, but to move through a few frames. So the big important things here are size increment, bounce, friction, and collision noise. Size increment, basically, a lot of times what happens is you'll have a collision and the objects will actually, like, the mesh will go into the other object a little bit, right? So they'll intersect in a way they shouldn't. And size increment basically allows you to grow or shrink the collider around the outside of your object. So this cube could have basically like a 1 centimeter gap around it, which might make it so those intersections don't happen. But the other fun parts are bounce, friction, and collision noise. So let's take our bounce and boost this to 100%. And, oops, I'm going to pull back out, hit play, and you'll see what happens. And I have the move tool selected, which really shows you how an object is flying. Hold on, let me just go H, there we go. All right, so this is bouncing. I'm not quite sure why it's so, why this object in particular is so excited to fly in all sorts of different directions, but it is. So I'm going to go ahead and stop that and pop it back to 0. It may be that it's high enough up that it's just, sorry, that it's just doing. And you'll notice if you adjust the height, you get substantially different results. This is obviously, for some reason, just bouncing like crazy. Yeah, I set bounce to 100. So if I set that down to 50 and try it again, you'll see it's like, right? That seems more realistic for certain objects. If I set bounce down to like 0%, and run the simulation again, right? It basically just falls, and it looks like it tips to one side just a little bit. If I set my collision noise to 0 as well, then I'm actually, oh, it must be on the other tag. We'll talk about that in a second. So friction doesn't necessarily matter so much right now, but if I set that to 0 as well and maybe set my bounce to 25 or 24, something like that, right? It doesn't really matter at this point because the plane is perfectly flat, right? But if the plane was at an angle, this object might start to slide across that surface, right? If I set my friction really low. The other thing to note is that bounce and friction and collision noise don't just exist on the rigid body, they also exist on the collider body. So if I come up to my plane and select that tag, you'll notice that bounce is 100%, friction's 100%, and collision noise is 5%. So if I set, or 0.5%, if I set collision noise to 0 on that, and I think I've set it, set it to 0 on the other one as well, and pop this back, let's see what happens. It's still doing basically about the same thing, which is kind of odd. It makes me happy, though, that it's deciding to bounce like that. All right, so I've got my cube. You'll note that there aren't as many options here, but something I want you to also note is that all of the same tabs are available for this collider body. And you can essentially change, you can turn it into a soft body. You can really change any of these tags to any of the other tags. They're just sort of presets that turn certain settings that are commonly used on and off. Okay, so let's select our cubes collider or rigid body tag, and let's go ahead and look at some of the other options that we've got. The first thing I'm going to do before I jump into that is I'm actually going to just expand this in a couple directions so it's a little bit flatter, and then I'm just going to go ahead and play this and make sure it's about where it, yeah, okay. So we get like a little bit of bounce there. Okay. So if I come over to mass, there's a couple things you can do. I mean, basically it's like how massive is the object, right? And density is an important part of that. However, this is what mass really controls. The biggest thing that it tends to control is what happens if this object hits another object, right? If this object has a much higher density than another object of the same size, and they collide in physics, it's going to move, it's going to change its velocity a little bit, and it's going to launch that other object really, really far, right? So that's what it's typically used for. However, you can also set a custom center of mass. And so if I have my object here, right, currently my mass is centered right here in the center of the object. But if I set this offset to say, I'm just going to say 50 in one direction, and I run this, oh, hold on a second, and I jump back to 0 and I lift this up enough so that it can actually make a change. It should change how it moves. Let me see what size this cube is real quick. Maybe I can pull it further off center. We're going to leave it off center, and we'll talk about another setting here in a second. But I'm just going to go really far out of whack with this. Okay, all right. So did you see how it's working now? Right, the center of mass is like way off to the red arrow direction, and so when it hits that, it actually kind of catapults off the side of the plane, and that's because, right, if your mass isn't centered in an object, right, that's going to offset how it rotates and falls and spins. So let's uncheck this custom center because we don't want that to be happening while we look at these other options. The other things that we can set are forces. So one of the most important ones, if I zoom in here, are the aerodynamics. So I can set this to have drag and lift, right? And what that also means is that if this is flying through, you can imagine that if I have aerodynamics turned on, it's like we actually have air in our scene, right? We have a specific air density, and you can somewhat model, like accurately model flight characteristics. So drag, if you want something to fall like a feather, you can boost your drag to say 2,000%. And so if I run this now, you'll see that it's falling much, much, much more slowly. Now you'll also notice it's falling slowly enough that I'm not even getting down to the plane in the 90 frames that I have available. And so what I need to do is I'm going to pause it, and I'm going to come down here to where it says 90. I'm going to boost this up to 400. When I do that, that'll now make it so that this animation will play for 400 frames, which should get this to right, very, very gently descend. If I set the lift to some value over 0%, like say 1,000%, and run this again, it'll actually get to at least earlier, it got to a place of equilibrium. And maybe not, maybe this one won't. But when I was testing it, it actually like stopped working at some point. But it looks like you can just see it actually, the lift basically slows it down even more, because now I get to 400 frames and it either barely touches the surface or doesn't at all. And yeah, so, right, so you have lift and drag. Now, the other thing with lift and drag is if I'm going to set both of these to 100%, not 1,000. And I'm going to stop this. And so what I can do is, I think we used forces in the particle tutorials, correct? Where you could bring in turbulence and all of that to control things. So you can use turbulence, wind, all of that with the physics engine as well. You just have to make a change. And so I'm going to go ahead and go up. You can't see it, but I'm going to go up to the simulate menu at the top of the screen. I'm going to go down to forces, and I'm going to choose just to keep it simple, I'm going to choose wind. And I'm going to move the wind generator a little bit so we can actually see it, because purple and gray just don't work well together. I'm going to zoom in a bit. If you remember, with the wind, it tells you what direction that force is going with that little purple arrow. And so in order to get these two things to work together, there's a change that I need to make. Under the mode, if I select the wind object and I go down to mode at the very last option under the object tab, I can change that from acceleration to aerodynamics wind. And this is what tells the physics engine to use this and impact the objects based on the wind. So if I zoom out a little bit here, so we can actually see this cube, and I run this, you'll see the wind is slowly pushing the cube right off in that direction. So it's still falling along with physics, but it's being pushed away. If I go and add another force, if I maybe throw a rotation on there and change that to aerodynamics wind as well, I have no idea what's going to happen when this comes back up. Yeah, it's doing something. It's hard to see exactly what's happening here. Oh yeah, you can kind of see it going back and forth, like it's rotating some. Okay, so we've got those forces going on. I'm going to go back to the rigid body tag on the cube. And just something to note, there's this very last option here under where it says two-sided. And so two-sided means that both surfaces of a polygon will have wind and aerodynamics affect them. And so this is, when it's an enclosed object like a cube, doesn't matter. But if you're trying to do something like a sheet of paper or a leaf or some other thin object that is just a single polygon thickness, then it means that lift and drag will affect both sides of that object. And so you get more realistic motion that way than if it was not two-sided. So that's just something to note. Okay. So this is great for doing a single object, but I'd like to show you what we can do with a cloner. So let's go ahead and stop this. And let's go ahead and create a cloner. And then let's go ahead and create a sphere as well. And we're going to make the sphere radius like, let's make it 10 so it doesn't take up the entire scene. And we'll make the sphere a child of the cloner. And you can kind of see it actually laid those out there. Let's go ahead and lift our cloner up. And we're going to go ahead and take our cloner and let's make our count. Let's just do 10 by 1 by 10, which should be a lot. And maybe we can, if we change our mode from endpoint, from per step to endpoint, let's make that instead of 1800 centimeters, let's just make that 180. Is that gonna, it's gonna have to be a little bigger than that. 200? Let's do 300. And then we'll do 300 in this other one. Okay, so we've got this reasonably dense set of spheres. And so now let's go ahead and select our cloner, and we can either right-click on it or go up to tags here, and let's add a rigid body tag to the thing. So under simulation, rigid body. And I'm just going to go ahead and hit play. I'm actually going to bring this back to center, then hit play. Right, and so you can see, right, all of these clones fall as a single object down to the surface. And they're not bouncing a whole lot. It might be more exciting if they did bounce. So let's go ahead and go to our collisions tag and make our bounce like, I don't know, 40% or something. Oh, and I didn't say this earlier, but collision noise just basically means something happens and it tweaks those values a little bit when it lands. So it intentionally doesn't collide perfectly. Okay, so now we've got this bouncing. Oh, that's really interesting. It's doing what I thought it was not going to do by default, but now here it is. Okay, so something to note as we're doing this is that if I hit play, right, now that they've bounced and stuff, they're all rolling around as individual parts. And the reason for that is because this, by default, the inherit tag up here is apply tag to children, right? So that means that every child object in the cloner essentially has physics applied to it individually. If I want these all to fall as a group, what I do is I change this to compound collision shape. And now that I've done that, you can kind of see in the corner there, right? It's acting as though it's a solid sheet of material, even though clearly it is not a solid sheet of material. Okay, right, so that's pretty exciting, right? We've got our cloner. We can either have it all be one, or we can apply a tag to children and have it fall through. So that's, right, this is the basics of of the rigid body tag. There's, you can add additional forces. There's other things you can do here. Again, as always, if you right-click on anything, you can go to Show Help, and it will load the help and tell you basically what that setting does and why it's important. Which there's so much in there that I can't possibly go over currently. Now, there's some other things to note here that are important. So one of the things to note is this under the Dynamics tab. I've played this through until these spheres are all kind of hanging out next to each other in like an irregular shape. What I can do is, now that I've gotten these in this place, I can go under my Dynamics tag and I can set this to be the initial state. So if I click Set Initial State, what this does now is if I go back to frame 0, and it actually worked, those spheres should stay where they are. But if I hit play, actually, hold on a second. If I was to say grab my plane and maybe move it a little bit lower and maybe rotate it a few degrees, and then hit play, right, the spheres will fall from wherever that last place was that I set as the initial state, and then they will go from there and drop. This can be really useful so you don't have to wait through like however many minutes of like, especially for a complex thing. If you're like, okay, this is where I want this simulation to start, you can set that initial state. And you can always clear it as well in that same tab. Something else that you can do, if I go ahead and play this and pause it somewhere in this animation, I'm going to pop back out, select the dynamics, select the tag for the cloner. And I'm not sure if it's going to let me, with a cloner, what exactly I'm going to be able to do, but we'll see. So, right, I can't, as you know, I can try and move this cloner, but those clones aren't going to go, right, anywhere because they've already been kind of locked in space by the simulation. However, if I uncheck this enabled option, I should, at this point, no, maybe the cloner doesn't work the same way. Never mind, I'd have to do this with the cube. Okay, so let me go ahead and actually enable physics on this real quick. And go down to my cube, select this, and so right now it's, right, the cube is locked. I can't move it anywhere. However, if I disable the dynamics for a second and maybe turn the dynamic off, I thought that's what did it. Well, maybe I'm, I got this to work the other day. But I don't know why it's, Can
you be at frame 0?
Well, yeah, so I thought that you could, I thought I had set it up so you don't have to be at frame 0. So you can, like if you're sort of happy with where something's falling, you can scoot it a little bit over in the simulation. But for some reason that is not playing nicely right now. Oh well. I'll look through that. I'd like to finish getting through this. And then figure out what I did that made that work previously. Okay, so these are still, right, falling, fantastic. You'll notice that the spheres aren't really reacting to the rotation or the wind. And that's because on this tag under force, my drag and my lift are set to 0% by default. So if I want them to be impacted by these things, I can put 100% on there. I have no idea since they're already pretty low. Oh, it actually, the wind's actually blowing them up the ramp. a little bit, which is hilarious. And then they're all getting coalesced together and flying away very slowly off into space. Yeah, so, right, so I'm going to set that back to 0 and 0. You can also include or exclude forces that should impact this, which gives you just a lot of control if something isn't moving the way you want it to. Okay, so we've done all of these things. Let's go ahead and look at the soft body tag. So we're going to create another sphere to start with, or maybe, actually, let's create a platonic. And we can just leave it as the default state. I am going to shrink it, though, a little bit. And I'm going to go ahead and do display and Gerard shading lines. So we can see this, and then a little bit better. And then I'm going to adjust the number of segments here. I'm going to set it to 5. Yeah, that should be plenty dense for what we're doing. Okay, so I've got my icosahedron, and let's go ahead and select the platonic in our object hierarchy and either go to tags or right click and go to simulation tags and Softbody. I'm going to hide the cloner for a bit just to mellow things out a little bit. I'm going to leave the cube there. It's above us, right, somewhere. Yeah, this should be great. And I might try to make sure they're aligned. So I'm going to grab this and just scoot it over a little bit because I honestly just want to see what happens. Okay, so I'm just going to leave the default settings on the soft body, and I'm going to hit play. And you'll see that the icosahedron gets all squishy. Oh, I'm also going to take my cube and I'm going to zero out the drag and lift on the force tag or tab, just so that it drops straight down and smashes the icosahedron flat. All right, so why did it, oh, weird. So yeah, so the icosahedron drops down. For some reason, it doesn't reset to the right position when I go back to frame 0, but that's fine. I'm going to hide the plane, or not the plane, sorry. I'm going to hide the cube as well temporarily because I really just want to focus on the platonic. There we go. And I'm going to lift this up a little bit higher, and I want to look at some of the soft body features. So the soft body is, you'll notice it's all the same settings. Under dynamics, I can set the initial state. I can turn it on and off. Under collision, I can do size increments. Notice there's this option that says keep soft body shape is checkmarked. I can make it bouncier, so I can say, 50%, so it doesn't just flop when it hits the ground, but it actually bounces a little bit. Although, right, it's not bouncing so much because it's a soft body and it absorbs that force. So let's look at what we can do to adjust this. If we click on the soft body tab and we come down here, you'll see there's a lot of options. There are, and they go, the instructions, the manual goes through this in depth, and it shows you what different things do, but this is the best illustration of what these, of what the different springs are, right? So structural means basically how much can the space between the points in your mesh change along the edges. Shear is how much can those stretch across the polygons. And then flexion is more like rotation. How much can those points rotate? And when you put it all together, you get somewhat complex things. So, oh wait, that's right. I'm gonna have to, sorry. I have to close this. So you'll see it, like the structural is set to 100. If I set this to 1 and run this simulation again, which I'm going to try and leave it large, you'll see that it really deflates a little bit, right? It loses all structure and it just totally flattens out. The other thing I'm going to do is I'm just going to set this to 200 frames instead of 400, so it goes a little bit faster. Okay, maybe I'll go, hold on. Maybe I'll actually just do 100 frames for now, since this is a pretty quick. Okay, right, so it smashes down, lays flat, because I have the structure set to 1. If I set the structure to 50, you'll see that it squishes down and it slowly kind of, it's more like a slow leak in a balloon or something like that, where it just slowly changes. Okay, so stop that. If we set that back to 100, and we can make it stronger by going over 100. If we set shear to 1 instead of 50, right, you'll see that we don't see quite so much of an impact in terms of what its shape is. If I set it to 100 and run this, it should be just a little bit stiffer, right? There's not a whole lot of change there. Now, if I set Flexion to 1 and run this, right, you'll see that it really turns into basically like a loose piece of cloth, right? So Flexion makes a really big difference in how this object maintains shape. If I set Flexion to, oops, not to 0, that would, I don't know what that would do. Right, again, it's going to keep its shape really well. Okay, so those, you can adjust those, you can adjust the damping, you can adjust the elastic limits. There's a lot there, but I want to kind of go on to the last couple settings and then we'll be done with this. So there is this shape conservation where you can set a certain amount of stiffness. So if I set that to, it's set to 0 to start with, if I set that to 10 and start this over, you'll see that it's soft, right? But it stays a lot more, it's, even though I have those other settings a little bit squishier, it keeps that shape better, which, you know, you would hope that's what it's supposed to do. I could make that even more stiff, but I'm going to go ahead and put that back to 0. The bottom set of things is pressure. So if I go ahead and set this pressure to, I'm just going to set it to 100 and pop this back to frame 0 and run this, you'll see that it actually inflates that mesh. And so if I was to set it to, say, 1,000, it inflates it substantially more. Eventually, everything will become a sphere, right? If it gets big enough. And so these, and then pressure also makes it maintain its shape, or whatever shape it goes to, because, and I could set my Flexion lower on this to say 1. And you'll notice it doesn't make a huge difference because the pressure, that internal pressure kind of overwhelms the rest of the shape. Okay, so so these are like, this is physics, right? This is kind of the basics. Something to note, it's usually a good idea to keep anything you're working with physics, you want the fewest number of subdivisions possible, right? So even if I set this to, I don't want like 1 probably for this, but maybe if I set this to 3, or maybe let's just say 2 subdivisions for this one, and inflate this, right? that simulation's gonna render a lot faster, right? It's gonna be computed a lot faster. And so something you can do is once, like if you're happy with how something looks, let's see if I can actually, I kind of want this to deflate a little bit. So I'm gonna set my pressure back down maybe to 1 and see what happens. Okay, so let's say, and maybe I will set structural to 50. Okay, so let's say I'm happy with how this deformed and flattened out. I'm going to hide the plane for a second so we can kind of look at that. So, but let's say that I want this to be, actually, hold on, let me make it crumple a little bit more. Oh boy, I'm hoping for something like I got the other day, but that's really just not working. Okay, so it's pretty crumpled. It's like really flat. But let's say I want this to look more like a blob than it currently looks, right? It's pretty low poly. I can always apply a subdivision surface to it. So if I create a subdivision surface, drop this platonic in there, right? I'm going to get a much more rounded and blobby form, right? And so what's nice about that is I can, it doesn't really, oh, that's gonna go forever. Because there's no plane for it to, this is probably gonna cause some problems. Yeah, so I don't, yeah. Right, so the subdivision surface really will allow me to basically do the computations on a simple mesh while having smoother results. If I was to take a cylinder and make it editable and get rid of the caps real quick. I have to go back to Morgan's one. And then was to apply, I'm just going to grab the Softbody tag from the platonic and put it on the cube, or put it on the cylinder. And if I was to run this in its current state, right, there we go. So, right, this is sort of collapsed on itself. It's pretty low polygon. Again, but it's got wrinkles. Like I could be using this to create some sort of cloth, or maybe it's a soft body object that gets used in some other way. But now if I was to make it a child of this subdivision surface, you can see that, right, that smooths things out pretty effectively. And you can get, you know, pretty nice like simulations of shapes and things falling and forming. Using those two objects. The other thing is, like, sometimes you want to do this, but you actually want to be able to use this mesh and manipulate it in some way, shape, or form after you've applied physics to it. So then all you would do is you would right-click on the subdivision surface. I think you can just say current state to object. Yes. And if I was to hide all of this, this now should just be, this is just a cylinder object that I could come in and manipulate in any way that I see fit. So you can always take any of those simulations that you've done and essentially freeze it and make it a solid object. It's also really fun to put like textures and materials on these because they deform with the shape deforming. So, you know, if Bob Ross's face was on here, it'd be all squishy and weird. Yeah, so that's like the introduction to the physics engine. The basics are really simple. You add the tags and it works. Getting soft body stuff to do what you want it to do can be more challenging because there's so many options. You can also, we haven't really talked much about vertex maps, but a vertex map, you can basically select certain parts of an object and that either have have a different amount of effect. So you could have a soft body tag on this and you could say, well, I want this part of the object to be really stiff and this part of the object to be totally, you know, flexible. And you could apply that and get something to droop or hang or whatever. Yeah. So that's the introduction to physics. It's fun. It's especially fun when you add like a lot of objects to a cloner and you watch it go crazy. One other thing, in the demos that I showed you, did I show you how to use a particle generator to create really blobby shapes? Okay. So something, maybe that's just a different day. We should stop right here. So I'm going to go ahead and stop this.